Today we're going to look at using the chain rule to solve three fairly complicated problems. In this video we'll examine the chain rule, and we'll also use the quotient rule and the product rule to differentiate these three functions. So in a minute what I'll do is I'll start with the first one, we'll work through it, and then we'll work through the other two as well. In the first two, we're going to take the first derivative of each of these functions, and then in the last one, the third example, the third problem, we're going to take the second derivative. So first we're going to have to find the first derivative and then take the derivative of that. So to take the second derivative of this function here. There's going to be a lot of algebra involved in this as well. So let me erase this and get started with the first problem. Okay, so we have our first problem here. We're going to take the derivative, find the first derivative of this function. But before we do that, I'd like to invite you to subscribe to our channel, click the notification bell so you can be aware when we put out new videos. We're going to be putting out several videos a week, so we have a lot of activity on the channel. And then if you can like the video and add a comment, give us some feedback, that'll be super helpful. As well as suggest some problems. If you have some problems that you'd like us to tackle with the chain rule or differentiation in general, put them in the comments, and then we'll work on them. And if we do, we'll solve them. We'll put them in the comments. Our answer will be in the comments. And if we select your problem to do a video on, we'll give you credit for that. So that'll be good. So these are advanced techniques for the chain rule. I have another video which you can see here for introducing the chain rule. We do 3 examples in there that are a little less complicated. So if you're not that familiar with the chain rule, you can go ahead and take a look at that. In this case, we're going to solve this problem using the chain rule, but we're also going to need the quotient rule. And so there's a video for that as well, and you can see that there's a link in the comments or in the description of the video, and then there's also a link up here for you to see if you need to go back and review the quotient rule, you can do that too. Okay, so let's get started on this problem. So we're going to start by saying y prime equals, we're going to do this outer part first. I like to break the chain rule up into chunks. First you start on the outside and you work your way in. So we're going to differentiate that, and then we'll take that result and multiply it by the differentiation of this. And this is really what this formula says here. So that will be 3 times the quantity 4x plus 3 divided by 5x minus 2 squared. And then we're now going to need to take the derivative of this. So that'll be multiplied by the derivative with respect to x of 4x plus 3 divided by 5x minus 2. So we're going to need to find the derivative of that. And in order to do that, we are going to use the chain rule, and we'll use some notation here. We'll call this P of x, and we'll call it h of x. Okay? And the quotient rule, I said chain rule, I meant quotient rule. The quotient rule here says that the derivative of this equals the derivative of p of x times h of x minus p of x times the derivative of h of x all over h of x squared. So we're going to use this to solve this piece. Okay? What I like to do, I don't like to write this stuff 100 times, so I'm going to circle this and remember that that is section 1 as defined here. So we'll have that, we'll use that in our final answer in substitution. We're just going to work on this section now. Okay? So to find the derivative here, we need to define p of x, and that equals 4x plus 3. And the derivative of p of x equals 4. And then h of x equals 5x minus 2. and the derivative of h of x equals 5. Okay, so now let's use this function here to solve this, okay? So if we take this down here, we get the derivative of p of x, which is 4, times h of x, which is 5x minus 2, minus the derivative, or minus 4x plus 3, which is, 4x plus 3 is p of x, times the derivative of h of x, which is 5. And that is all over 5x minus 2 squared. Okay, so now we have to simplify this. So let's do that. We'll just say, figure out what it equals here. So we have 20x minus 8x, or I'm sorry, minus 8, minus 20x, minus 15, all over 5x minus 2 squared. Okay, so we can simplify this. We'll simplify this here. We can get rid of the 20x's, they cancel, and this becomes minus 23, okay, the top, and then this is the same. So we can solve now. We know y prime equals 3 times 4x plus 3 divided by 5x minus 2 squared. And so, as you notice this, I'm going to just rewrite this a little bit differently. We can write it, we can really write this as, and this will help us simplify it in a second. That's what we had before, but I'm going to rewrite it, okay? We can rewrite this as squared, okay? That's going to be times this, which we just solved, which is minus 23 divided by 5x minus 2 squared. Okay, so now we have everything we need to solve this. We can simplify this down. So y prime is going to equal minus 69 times 4x plus 3 squared divided by 5x minus 2 to the 4th. Okay? And that's our answer. So we were able to use the chain rule, and then we were able to use the quotient rule to solve the second part of the derivative. And then we got this answer here, which is minus 69 times the quantity 4x plus 3 squared divided by 5x minus 2 to the 4th. And that's our answer. Now I'll erase this and we'll go on to our second example. We're on to the second problem. In this problem, we're not going to need the quotient rule or the product rule. This is a really nice example of just the chain rule. We're going to use it 3 different times. So like we did before, I started with the outside, working our way to the inside to the most simplest function we have. And so that's what we're going to do here. We're basically going to just do the chain rule in 3, or we're going to take derivative 3 times, and we're going to use the chain rule twice. So let's start. So we get y prime equals 2 times the bracket stuff, which is 6x plus x to the 5th to the minus 1 plus x, all to the 1, which we'll just call straight away like that. Then we have to take the d derivative with respect to x of the second piece, which is this function now, which is 6x plus x to the 5th to the minus 1 plus x So to take the derivative of that. Now, what we did before is, so we don't have to rewrite this all the time, we'll take this, put a box around it, and that is 1. So we have that. So at the end, we'll just multiply all the boxes in blue together to get the final answer. Okay? So let's take a look at this. So if we we just differentiate this piece is going to equal minus 6x plus x to the 5th plus 1 times the derivative with respect to x of 6x plus x to the 5th. Okay? So we can rewrite this a little neater, just to make it a little more common, like that. You make that 1 minus that quantity. So this is the second piece. So let's put our box around that. Here we go. So now we have the second piece solved. Now we're working on this last piece, the third piece. We're working on that right here. And so if I take this and take the derivative of it, then we get 5x to the 4th plus 6. And that is going to be the third piece. So now we have y prime equals the first piece, 2 times the quantity 6x plus x to the 5th to the minus 1 plus x times the second piece, which we can just write like this, 1 minus 6x plus, this is to the minus 2. Sorry, made a mistake. Plus x to the 5th to the minus 2 times 5x to the 4th plus 6. And that's our answer. So you can see, we really just did the chain rule 3 times, figure out your plan, work from the outside in, and then put everything in boxes so you don't have to write things 100 times, and then go ahead and chain them all back together. So like if you're on an exam, this will be a good technique to use. You're not going to be writing all the stuff every time, and then it'll save you some time so that you can make sure you get a good score and go back and check your work on your exam as well. So let me clear this off, and then we'll get to our third problem, and then that'll wrap up this video. So we're on to problem 3. Now problem 3 is a little bit different in that we have to find the second derivative of y. So the definition of the second derivative of y is the derivative of y, take the derivative of y. So that's what this expression says here. So we're going to solve this. First we're going to go through and get the first derivative, and we're going to pause for a second, rewrite things, and then get the second derivative. And it's going to get a little complicated. This is a pretty seemingly simple function, but with the chain rule, and then you can see we're going to have the quotient rule involved as well. It's going to get a little bit messy, but we'll work through it. You'll have no problem. We'll take the time and we'll break it down. So if you haven't already, this is a really good time for you to subscribe to our channel and hit the notification bell, and then you'll be aware of the videos we're putting out. And then also, if you want to leave a comment and hit the like, that would be much appreciated. You can give us some more problems to solve, and if you do, we'll do our best to try to solve them and post the answers in the comments section. But we'll also, if we take one of your suggestions for a problem and solve it on a video, then we'll give you credit for that. And we appreciate the support for the channel. Okay, so let's jump in. So what we're going to do like we always do with the chain rule, we're going to start on the outside and work our way inside. So the initial part of this is going to be y prime equals 3 times x minus 1 minus x squared times the derivative of x over 1 minus x. Now, right away you can see that this piece is going to be the quotient rule, but before we get into that, let's circle this piece and put a 1 around that, because that's the first part. All right, so let's work on this one. And so the quotient rule, as we know, we're going to take the derivative of this times this minus the derivative of this times this all over this squared. So let's work that out. I'm just going to take this section here and bring it up here and start to work on it. So the derivative of x is 1 times the derivative of 1 minus x, I'm sorry, times 1 minus x, right? Minus x times the derivative of 1 minus x, which is minus 1, divided by 1 minus x squared. Okay, so let's simplify this piece now. So we have 1 minus x minus a minus x, so that's plus x. So that's just, we'll simplify that in 1 second, plus over 1 minus x squared. Okay, so now we can get rid of those two x's, and this equates to 1 over 1 minus x squared. Okay, and that's the second piece. So we get y prime equals the first piece, which is 3 times x squared, whoops, we'll just call it 3x squared, much easier. 3x squared over 1 minus x squared times 1 over 1 minus x squared, and that equals 3x squared over 1 minus x to the 4th. And that's our answer for the first derivative. Now what we have to do is we have to take the derivative of this function to get the second derivative. So let me go ahead and erase this and get set up for taking the derivative of this piece, and then I'll be right back. I've rewritten the result we got before here, and now we have to differentiate this function to get the second derivative of y. And so what we're going to do is we're going to straight up use the product rule, but you can see here there's going to be a little chain rule embedded in that. So it's going to get pretty messy, but we'll walk through it and we'll take our time, and hopefully we get all the signs right and all the terms, and we'll do this in one take. Okay, so let's see. Let's take this and take a look at solving this by using the quotient rule. So the quotient rule says take the derivative of the numerator, which is 6x, times the denominator, which is 1 minus x to the 4th, minus the numerator times the derivative of the denominator. And now this is where we get into some chain rule action. Okay, so we're going to take the derivative of 1 minus x to the 4th. Okay, so, and then that's going to be all over 1 minus x to the 8th, because this is squared in the numerator here. Okay, so what I'm going to do, so we don't have to write this all over all the time, we're going to just take this little piece right here and we're going to go do the chain rule on it, okay? And so if we use the chain rule, we're going to have to solve, we're going to take the derivative of this whole thing and then take the derivative of the inside, okay? So the derivative of this is going to be 4 times 1 minus x cubed, right? And then we have to do the derivative of the inside, which is going to give us a minus 1. I'm sorry, that's not the derivative of minus 1, it's the derivative of 1 minus x, and that is minus 1. So this will be minus 4 to the 1 minus x cubed. Okay? So that is that piece. So, if we substitute that back in here, we get y prime, sorry, you stay with convention. We're going to get y prime equals 6x to the 1 minus x to the 4th minus, let's take this and put it in here, and that's going to be plus 12 x squared times 1 minus x cubed. All over 1 minus x to the 8th. Okay, so I did have a little break because I made one little mistake, so now I'm going to come back and finish the problem, okay? So I didn't get it in one take. So y prime is going to equal 6x times 1 minus x to the 4th minus plus 12x squared times 1 minus x cubed all over 1 minus x to the 8th. Okay? And so now we can simplify the numerator and actually simplify the whole expression, because we see there's a 1 minus x cubed, which is common here. So you can get rid of this. We can make this just 1 minus x, and then we can make this the 5th. Okay? So now, what does that give us? Let's simplify the numerator and bring this over. That equals 6x minus 6x squared plus 12x all over 1 minus x to the 5th. Okay? But what this really is equal to, this should be squared. Sorry, that's squared. So this is 6x plus 6x squared all over 1 minus x to the 5th. So, factoring out a 6x here, we get y double prime. So y prime of that, right? We find it, but the ultimate answer of y double prime equals 6x times 1 plus x all over 1 minus x to the 5th. And that is our answer. So let's quickly review. We took this function, we found the first derivative of it, then we had to find the derivative of the first derivative, which was this function. We used the quotient rule to do so. Inside the quotient rule, we had a little chain rule problem, which we solved here, and then we simplified algebraically the expression, and we were able to bring this to this, and that's our answer. Thank you for watching our channel. Thank you for subscribing and supporting us. We'll see you on the next video.